Thank you very much. So welcome. I hope you enjoyed the lunch. So today I want to talk about RAG, more specifically a system and how to build a system that's going to react to the knowledge of either public or internal documents that are happening real time. So we're going to do a quick demo. We're going to ask a bot about a question that can't have the answer. And we're going to change that in a second. So let me introduce myself. I'm Thomas Neubauer. I'm CTO and co-founder of Quix. And before, I worked in motorsport, in F1 racing, which is where the idea to build what I'm going to show you today in a demo and also in the slides. We are building real-time AI pipelines in Formula One, and this is where I kind of saw how a speed of innovation can be halted by cross-team dependencies. You need IT for everything, and really infrastructure is in the way. So I'm going to show you today our answer to that problem. It was quite a challenging use case, but you can imagine mostly sensor data coming from a cars at huge velocity and deploying AI models to just react fast to the situation on the track. So, just so I understand my audience, can you just raise your hands if you use on a daily basis pandas in your work? Okay. Who is using LLMs on the project? I don't mean like a end user, but who is using LLM on their project? Okay. And who is using Kafka on their project? Great. All right, so let's just quickly gloss over the RAG and what it's going to really means for us today. So, as you probably already know, RAG is about ingesting the context of knowledge into your questions and giving you an answer that doesn't contain just the pre-trained data, but something that might be just internal for your organization. Now, in our case, it's going to be two sources. It's going to be a docs for our open source library quick streams, and it's going to be community Slack messages in public channels. Because we are building a chatbot here that's going to serve developers using this library for just getting around the API, solving the bugs, etc. So what we want to achieve here is when somebody has a problem and somebody from our community answers that problem, at that moment, if somebody else asks it, they will get the answer from the community Slack. That's basically what we're trying to achieve here. So we're going to get an ingestion pipeline to our vector database, and then we have a user asking a question, and we're going to query top-end documents from this database, and we're going to put it into our prompt to LLM to get most accurate answer. Now you can imagine this is going to work in law firm when you want to mine the documents for the case, and you want to wait for the budget job to really ingest data into your database. So this is really where the difference gonna really be contrast here. So what we're gonna talk about is the top pipeline. So we're not gonna build it in a batch architecture today, but we're gonna build it using a stream processing pipeline. And that will give us that sub-second reaction time to whatever happening in your knowledge base, the answers of the bot. So in a typical architecture, you would probably ingest these messages into some database, and then maybe once a day or once an hour, you would load these documents that appear there, and you would create embeddings, and then you will save it to the database. So from that moment, it will be available for the context enrichment. Now what we're going to do instead, though, we're going to ingest data into Kafka topic, and then we're going to build a set of microservices consuming this data real time to embed the vectors into the document and do some pre-processing, and at the end, landing this data into Quadrant vector database. So, if you want to do that, you basically have two options right now to do it. You can either use Kafka or similar broker technology and its client libraries to build a couple of microservices that's going to do this. And then you land data into the favorite database. Now, problem with that is when you need to build something stateful. And I will just talk about that in a second. Second option is to adopt full-fledged stream processing framework like Fling or Spark streaming. That's not a silver bullet either. So the first option is quite elegant. You have a support from big companies like Confluent and others from Google for their pop and sub. So you get a really nice library, and you don't bring really any dependency on Java, etc., into your project. However, the moment you get from a simple, stateless, one message at a time processing, so for example, when you're just converting one Slack message to something, that's fine. But when you, for example, want to create a thread, because the messages are coming not connected to threads, at that moment, it gets really, really complicated. And I would not recommend building that in-house. And at that point, you might be tempted to use something like Spark or Fling. And if you do that, well, your life gets also a bit difficult because it's a quite complex architecture. It's a lot of Java in your life, which is something that you might not want working with AI. And debugging is difficult. Lots of exception coming to you going to be in the Java, really. And then all these services that going to do something with the Python ecosystem, like vector embedding, you're going to be fighting with the UDFs, where you basically connecting a Java world, which all these frameworks are built in, with the Python world, where all these libraries are available. And this is a friction, because you need to make sure that everything you use in these functions can be redistributed in your cluster. So, is there a third way? Well, that's what I want to show you today. And it is basically combining the approach 1 with a platform, which you can see in a second. So this is how the Quix platform looks like. And the idea is that you solve data ingestion, data processing, and syncing your data and data serving to applications all in one unified environment where you can set permissions and everything. So you don't need IT or other teams to innovate, to try a new thing, to just spin up a new infrastructure for a new idea that you have. And that's kind of what this is about. So let me show you first demo, because then we're going to go to our library called QuickStreams, which is solving the life of a Python developer. But first, let's go to the platform. So here is my pipeline, and what you see here is a lot of stuff. But what is important here is this bottom one, which is basically when we're getting messages from Slack. So every time somebody posts a new message or an answer to the thread, in the thread for some problem, we get that message from Slack. It's just a webhook. And then we aggregate these messages into threads because we're getting them flat. That's quite unpractical at the moment. Then we enrich these messages using Redis and Slack SDK to make sure that we get in messages things like a channel name and a author name and things like that are not really sent directly into the message. And then we go and we embed this message with the vectors. We do some transformation, we do some splitting into chunks just to make sure that it sort of works. And then we have a quadrant sing, which is again a microservice which is getting these messages now with the vector data sing into database in a reliable and scalable fashion, which is another great advantage of stream processing, that you can really horizontally scale this a lot, and you get the resiliency of the queue system, of the lock in the topics between the services. So now what I'm going to do, I'm going to go back to this corner where I have a chained application, which is super cool library. You can make services like this super easy. And I'm going to ask a question that has no idea how to answer, because I haven't shared that anywhere. So I'm just going to ask it. Will Thomas use Slack messages for his live demo in Data Hive? Well, unless something changed dramatically, it has no idea. All right, but what I'm going to do now, I'm going to go to Slack, in our community Slack, which is public, and I'm just going to share this information with the community, okay? So let's go to Slack. I have the message prepared here. There we are. And let's go here. Great. So now I have published this message here. And if I go to Quicks and look at this thing, you see that green bar in the Slack row? That's the message we have got from, and I'm going to make this a bit bigger. There it is. So this is the message. Well, it's quite difficult, but there we are. And if we go down, Thomas will use blah, 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 blah. Okay? So we have the message. And this pipeline immediately reacted to this message, created embedding all of the stuff up to the Quadrant sync. So now you see that there is a new vector document in our Quadrant. And as a result, if I ask again, it knows that I'm going to use Slack messages. And this is basically what this is all about. So now you can imagine how this could work in your organization when, whether it's public knowledge or internal knowledge, you basically know, well, the LLM immediately knows that something happened and answer the right answer. So going back to the presentation, this is possible by two things, really. The one thing is the platform. That wasn't the greatest. There we are. This is possible using a platform, so you can basically deploy all these applications and use the infrastructure under the hood to deploy it. But it's also possible because of the open source library QuickStreams. This library helps you to process data that are coming in a topic in a very friendly Pythonic way by exposing pandas-like data from API to stream processing. The reason is that coming from batch to streaming is quite a mental shift. You have to approach a normal common problems quite differently, and it's quite challenging. So as a result, we kind of thought what we can do here. And so we're exposing an API that under the hood is basically doing a lot of software engineering, really, working with the state, working with the Kafka checkpointing, and really something that you want to get involved under unless you want to build a new Flink. And we have done all of that and package it in kind of pandas style programming. So you're working with the data like they are in your Jupyter notebook, like they are in the memory, but actually it's just a promise of a transformation that will happen when data comes in later, maybe tomorrow, you never know. And that is what QuickStreams is about, and all that Kafka ugliness that's hidden under the API. So let me show you the last demo, what is called a streaming data frame, which is basically working with the data in a topic like it would be static, but it's not. So now if I go back to the platform and go to this pipeline, now I have here another environment called development. It's just a different branch of this project, and it lets me to basically just quickly prototype something without touching a production. It's kind of what a DBT did to a Git flow. So now I'm going to go here and I'm just going to create a new microservice consuming data directly from Slack. It's a bit zoom out so you can read it. So let's just use this name. And this would create a new microservice completely prepared to work with my infrastructure, with my credentials, with my Kafka and my Kubernetes. So I just don't have to really care about that. I just need to care about my Python. That's all I need. So here I can go here and just press run. And this code, without me touching it really, will, if I actually, because I ran this before, just make here some change to change the consumer group. So if I just run this, I will get the messages from the pipeline real time into my console. Now, it's going to be quite ugly JSON, as we saw before. And that's why I'm actually doing this. So let's say I want to get these messages into something more interesting. Maybe I'm interested in how many words per day or per hour is discussed in a Slack. So what I can do here is literally do classical work here. So I can say, okay, maybe do apply like that. And maybe I want to extract something from it. So maybe then give me only rows where we have a column, I don't know, text. How about that? If I press run. I will make it a bit bigger so you can read it. So it would give me a bit processed data, okay? There we are. It's still quite ugly. So let's just do a projection in pandas. Well, maybe just let's get a TS and text of the message. So I'm just going to go here and do something like TS and message. And now it's going to start to look a bit more friendly. No, it's not called message, it's called text. The good thing about this approach is that now we are not missing any data, even though I did a mistake. Great. So now you can see that some people joined the channel. And this is how you can process this data more and more. And then you can just pull any pip package from Python ecosystem and do encoding, do machine learning inference. You know, call your own LLM if you don't want to use OpenAI. But basically, from this moment, I'm just one click away from deploying this as a Kubernetes container. So I can enable public access if it's fast API. I can enable state if it's stateful operation. And I can give it different environment variables or different CPU memory. And then I press deploy, and this service is now deploying as another branch of this pipeline into my client environment. And this is a gist of how Quicks and Quick Streams work together. So, hopefully you like it. And if you have any questions, I'm obviously here. Yeah, you can give us a star on the GitHub if you want to. And thank you very much for listening to my talk.
Thanks, Thomas. So live demos do work. No blue screen. That's a Mac. Okay, no blue screen of that. Okay, so any questions from the audience for Thomas?
Yeah, just a very quick question. So regarding, so you see what the use case here is, but is this mostly for cases where someone has very large amounts of data coming in at high speed, generally speaking? Because I'm guessing for ones with a small amount of data, you might just like hit the API. And is this just for a case when someone's hit a bottleneck and then they feel they need to go beyond?
So it's a great question. Normally I actually have this slide included. So there's two main conditions to use stream processing in your project. The condition number one is when you have a lot of data, as you said, and you need to horizontally scale and use distributed compute architecture to solve your problem. The second use case is when you need to act to data fast. Because if you build a real-time system with APIs, you don't get the resilience and fault tolerance of a log-based system like Kafka Broker. So basically here, and actually it happened on the stage because I have implemented a faulty code in an API-driven system, I would lose these messages that just were happening when I was redoing these things. I could also read down and replay all the message in that topic. So this is a second condition. And a fault tolerance in a replication is also a great benefit. So you get your data always sent twice, 3 times to different regions. So if you have a compute failure or a transportation failure, so whether your Kafka Kubernetes is down, the system is still work. So that's another reason why to do that.
Do we have another question? Okay, let's thank Thomas again.